Hi everyone, my name's Alex, and I've spent a lot of time debugging coding agents, unable to steer them effectively, unaligned with what I want to do, especially when I'm working on more complex projects. And so, after a lot of experimentation, I wanted to bring together all my learnings into a procedure called Atomic, which I'll walk you through. It's an open source project, so anyone can try it out. So, right now, I've opened up the repo, and upon opening the repo, you'll see a README. So what Atomic is at a high level is enabling you to use coding agents, but with the software development lifecycle principles. And the goal is to create a foundation for effectively steering these models. I thought the best way to actually show off what Atomic can do is by giving a demo. So there's a feature that I was actually been interested in implementing in an open source repo called Agent Framework, and this is an open source project from Microsoft. Specifically, I wanted to add auto compaction, which is enabling the context window of language models to be shortened with relevant context so the context window doesn't get overflowed. And I wanted to add first party support for this in the agent thread class in Agent Framework. And here I've just written up an issue, just describes the context. This is actually inspired by the GPT 5.1 Codex Max model having a new slash responsive slash compact endpoint. The main types of compaction that I wanted to implement are summarization and the built-in responses compaction option, and then also a top K compaction where you select the top K entries from the conversation chain. So the first thing that I would do when using Atomic is clone the repo. So I've already actually cloned the repo. So I'll open up my terminal and I'll go to the Atomic Atomic project on my terminal. I'm going to be using Cloud Code for this demo. I've decided to implement the .NET part of this issue. Here, I'm just copying over the configuration files for Cloud Code, and I also have some configuration files for a dev container. The idea behind using a dev container here is containerization enables you to protect resources outside of your workspace and also allows you to enable cool things like firewalls. And so I find this is a really convenient way to enable the dangerous permissions mode in Claude while having the safety harnesses implemented. So once I copy over those files, I've already copied them over actually to the project. I'll just quickly open up the project. And the first thing that you should do when using Atomic is set up the Claude.md to provide the model context of the code base that you're working in. So what I'll do is I usually use a prompt like populate the Claude.md based off of the instructions provided in Claude.md. You do the same thing for agents.md, for Codex, GitHub Copilot, etc. We also have open code, for example, in Kiro. And what this will do is it'll instruct Claude to explore the code base and find the most important practice in the code base and test and build commands, just keeping it to the bare essential for a Claude.md, since it helps to have smaller Claude.md instructions to maximize performance and just have the model focus on the more important context that it needs to work with. While we're waiting, I'm just going to pause and I'll come back when the Claude.md is populated. Awesome, and we're back and the Claude.md has been populated. So now you'll see that the Claude.md describes the overall structure of the .NET project for Agent Framework. This will be incredibly useful in the next phases where the model just needs basic understanding of the project. So now let's go into the next phase of Atomic, which is the research phase. So this research phase involves the model having a task to work on along with docs, notes, and tickets. And then it spawns a research codebase agent, which has a codebase pattern finder subagent, codebase locator agent, codebase analyzer agent, and codebase research locator agent. And then there's also analyzer agent for research and also another online researcher, which can search for documentation online. And this is where dev containers actually become useful because you can put a firewall on the sorts of resources or online websites that can be accessed by agents like Claude Code. And what the codebase finder and locator analyzer agents do is they identify files that are relevant to the current task that's being solved. They try to aggregate relevant files, relevant code, relevant classes, relevant functions, etc. And then you also have the code-based research locator, which takes previous research from previous runs of Atomic that you've done, and it aggregates it to get a more holistic perspective of what are all of the research that could be relevant to the current research you're doing, if any. And then the online researcher will only be invoked when there's a need for an external dependency. And this allows you to actually use the Playwright MCP and DeepWiki MCP to gather more context about the external libraries that you're working with. So the way that you invoke the research subagent is, or the researcher agent as part of the research phase, is clear the context window because you generate the Claude.md and you don't need the additional context as part of this task. And you just run the research codebase subcommand. And what I want to do in this case is I have an existing issue on GitHub and I'd like to actually reference that. So what I'll do is I will tell the model that I have this issue and I'd like you to reference that. Another thing that I find helps ensure the consistency of the model is I like to pre-populate specs and research folders just so I can guide the model that it needs to generate these specs and research folders in the certain directory that I'm working in. I just find that it overall helps with consistency. So in the research codebase command, I'll usually start with research the proposed issue for auto compaction of agent thread in, and then I'll link the GitHub issue. Continue the research by thoroughly reviewing this GitHub issue and gathering the necessary context for implementing the proposed feature. So what this does is it will go through and invoke each of these subagents where they're applicable, and then try to create a comprehensive research document. This will be a more messy document. We'll see how we can narrow down this research document into a more organized spec after this phase. But what this will do is it'll go through and create the research document in this research folder. While that's happening, I'll actually go through the rest of the pipeline in more detail. So it'll eventually output a research output, which looks like the file directory structure I have on the right. And this just aggregates all tickets, docs, notes. You can even provide just markdown documents, text documents, etc. as the input to this research command. And the Atomic will try to figure out what is the relevant parts of these tickets, docs, and notes that you input. Once the research is generated, I typically auto compact or more often just clear the context window completely since the research is saved as static files that can be referenced later by the model, and then run a create spec agent. What this create spec agent will do is take the raw research and translate it to a clearly organized spec following principles in software engineering from Google, Amazon, and Microsoft that will be reviewed by engineers. So you'll review it, your team will review it. What I typically do is I'll submit a PR, have the PR only have a singular spec that you generated, and just quickly review the spec. And once the spec is kind of validated is when you'll move on to the next phase. And here's where things get interesting. The create feature list agent will take the spec that was generated in the previous step and generate a progress.txt file and also a feature list.json. So the progress.txt is a solution coming from an Anthropic blog that I read where they described that adding a progress.txt prevents the model from generating garbage files throughout the code base. If you may have noticed, sometimes files would just, models like Claude Code or agents like Claude Code will generate markdown files like docs that aren't necessarily the problem and just bloat the code base that you eventually have to remove. So this progress.txt allows the model to have some working memory of the process that it goes through while it's making the change and prevents it from making those garbage files in the process. And the featurelist.json is a way to ensure that the granularity of the changes made by a coding agent are small enough to where they can be reliably verified for correctness using deterministic testing principles. The format of a featurelist.json is a structured list of objects that has a category, description, steps, and the other important part is the passes flag is default to false. So the passes flag will only be changed to true depending on whether the tests pass. So here's where the agentic loop actually begins. So once you've manually went through this entire process, you'll invoke something called Ralph, which is inspired by Jeff Huntley, who took this idea of just running coding agents using a while loop in a bash script. And what I've done is I've refined it a little to take each feature, automatically compact or clear the context window in my case, and then implement the feature. So here's how the agentic loops looks like, or the while loop or the for loop. So I'll go through and identify, just parse the JSON for the featurelist.json and determine how many, if the iteration should continue or not based off of uh, are all of the passes fields set to true or not. So basically, while passes is false for all of the entries, the implement feature agent will implement a change, create tests for that particular feature in the feature list, and then validate the test. And this is where we go into kind of deterministic software engineering practices that are true and tested for these systems that actually don't go away when we're building these systems. So the deterministic side of things is having test hooks like pre-commit checks, linter checks, and quick tests that can validate whether a feature is implemented correctly or not. And so running these automated deterministic tests then allows the model to this procedure to branch out into two steps. One where it fails and it goes through a debug agent that will generate a debug report. And that debug report will then be translated to another feature in the feature list that will be prioritized above everything else to solve the current issue that's happening in the implementation. And so I tried to mimic this off how an engineer would kind of pivot if they face a bug and immediately try to address that issue. But otherwise, in the happy path, if all the tests pass and the model uh, didn't break anything, then you go and mark the feature as complete. The model will mark it as complete in the JSON, and then it will commit the change. And so the interesting part here is that the feature list actually isn't static in some sense because as errors are happening, the feature list is getting updated. And so it tries to mimic as much as possible the software engineering process where you're going through and splitting up a problem into subproblems and then further into subproblems, kind of following a recursive thinking strategy. Once that finishes, hopefully everything should be implemented as you had intended. Sometimes if things don't go right, you can always use the debug agent to go through and verify the parts that don't look right to you and kind of have this iterative process with the coding agent where you can revise them. Sometimes if the issue is super small, which most of the time I found to be small issues, I will just manually go and quickly fix the issue, whether it's just incorrectly adding something like enabling telemetry disabling telemetry when I wanted to enable telemetry. Okay, so this is the end-to-end workflow of how Atomic works. And one thing I wanted to add, this loop is only currently supported in Claude Code, but open to PRs and also working on possibly incorporating other coding agents with this implementation feature agentic loop. So let's see if the research code base is finished. So the research code base hasn't finished, so I'll come back as soon as the research code base process is finished. Great. Now we're back. The research has been implemented, And you can see that there's a research folder with docs, notes, and tickets. In this case, since it was an issue, it was created in the tickets folder. As you can see, there's a comprehensive research document that takes the initial issue that I had presented the research code base agent. It kind of built this long research document. What I'll usually do is I'll review it sometimes when I want to gain more context on what's the area that I'm building in. And this just helps me be more informed. And I use this as a tool so that I can have more knowledge of the system that I'm building in, especially if it's something that I'm not well adept at. So I'll typically go and read these research reports to gain context. But this isn't necessary. Most of the time, I kind of know what I want in a feature that I'm implementing. So I don't always read this. I read this kind of when I need the context and I'm less familiar with the subject area. Now let me run the create spec command, which will take this generated research and organize it into a more structured format that can be reviewed by engineers. What I'll do here is I'll basically go through the spec from top to bottom, and if it cites any research, I will go dig deeper into it if it's something that I'm unsure about or want more context in. And so this is where you kind of see the relationship between researching and then the plan phase. And just having an idea of the spec and making sure that you have a solid understanding and you're certain of all the things that are described in the spec is essential to ensure that you have success with these coding agents. So with that said, I'll join back when this create spec command is finished running. Okay, Cloud Code has now generated the specs, but I noticed that it's not in the correct folder. So what I'm going to do is I'm just going to quickly tell Claude to update the spec in and move it to the root spec folder in here instead. And then I'll just backtick that. And I find sometimes Claude Code will just, and other coding agents will output in the wrong directory. So I'll just quickly go and adjust it just to keep things more structured. And then I'll say update the links in the markdown file accordingly as well. Nice. Now the spec has been corrected, so the location is now correct. And what I'll do typically now in the review process is I'll open the spec up, and I'll just take a look through the spec. As you can see, it's a organized structure with an executive summary and then kind of the context of what the problem is being solved. And it's just describing the problem with long-running agent conversations, and then what are the goals and what are the non-goals. And then there's a nice system architecture diagram generated by Atomic as well, which I typically will read through as well if I need a quick summary and want to make sure that the spec is on the right track. So I'll actually start hierarchically and start from the high level with executive summary and then just dig deeper into the spec and make sure that every part of the spec that's being generated conforms to my principles and my preferences. So for the sake of time in this demo, I'll just quickly skim through this spec. Usually I'd probably allocate an hour or two just to review the spec, especially if it's a very large feature and is touching multiple parts. This demo is actually that case where you're touching multiple modules in the agent framework repo, which is a good test of kind of how these coding agents are able to work in more complex software engineering tasks. So once the spec is generated and you've gotten approval from the team, submitted a PR, and the rest of the engineering team says, looks good to me, then the next part of the process is generating this feature list. So what I'll do is I'll clear the context window and I'll copy the location of this spec. So I'll copy the relative path, and then I'll run the create feature list command. So what this will do, as I was mentioning earlier, was it takes the spec and creates a progress.txt and feature list.json, which will allow Ralph, when it's running for Claude Code currently, to be able to iteratively implement each feature required by the spec. And so what I'll do is, after I have this feature list.json, I'll run the Ralph script, which is included as part of the .claude folder. And this just includes a /implement feature command that will just get run over and over again. And there will be uh, a visualization of what's happening through piping the Claude output to a visualize.py script. So this allows you to open up a tmux session and then run the Ralph bash script or PowerShell script and be able to monitor your agent through a remote machine. So what I'll do is I'll typically allocate a remote machine or a dev box, and I'll run Ralph autonomously in a loop in a container and have it implement the feature one by one. And as it runs into issues, use the debug agent to report those issues and add it to the feature list.json. So let's wait for the feature list.json and progress.txt to be created. It looks like the feature list.txt has been implemented as well. As you can see, it just has all these features set to pass as false. And you have different types of features. You have functional features, and then there's also documentation and testing features. So in this case, since this is a not really a documentation change, it's heavy on the implementation of the functional feature and then a test category. After the feature list and progress list is generated, what I'll do is I'll open up a terminal window. This would usually be a remote connection, but in this demo, I'll just show you how it looks like when I locally run tmux. So what I would do is I'd create a new tmux session, and I'll call it feed, actually, also for feature. And this will create a new session in tmux that I can just detach from easily. Let me detach back. What I'll do is I'll run ralph.sh, and ralph.sh will detect the features that are failing or false as passing, and will then implement them sequentially and add the debug report features as well if it runs into any issues. So here you can actually see the type of output from Ralph, where the output of Claude Code is being piped through this visualize.py script, and it's just using the rich library in Python to actually display the output of the coding agent as it's going through the problem. I'll just go through the spec and make sure that all of the features that belong to the spec are implemented, and then I'll even do another kind of code review myself, just skim through for any issues, and really also use the tests to make sure that the feature is in the right track. So I'll leave this running in the background. My goal is actually to submit a PR for this eventually, so that there can be at least some POC of the auto compaction feature. But to quickly close out, the core of Atomic is researching, planning, and then implementing a feature with coding agents. And following this principled approach allows, in my experimentation, to achieve much better results when going through complex software engineering pipelines. And I've been seeing these systems work more and more, but I want to emphasize that we're still experimenting, and this is an open source project, so definitely open to any contributions. If you like the repo, uh, I'd love to get a star on the repo, and then feel free to submit any issues and pull requests with new features. I'm looking to actively develop and try to make software engineering with coding agents work for everyone. I can't wait to see what you build with Atomic.